This webinar is for people who are interested in using the TruckScience Axle Weight Calculator to sell safe and efficient trucks and avoid costly rework. I'm going to show you how to use the app to carry out weight studies, calculate centre of gravity, and generate professional reports. When we think of good work truck design, our goal is to build a truck with high payload capacity and low fuel consumption that avoids undue maintenance and of course is legal on the road. To show you how to use the axle weight calculator to help achieve these goals, I will run through a live example of a Ford F550 with a crane service body and a trailer. A quick overview of what we'll cover before we get into the demo. We're going to use the TruckScience library to find standard specs for vehicles, bodies and equipment. I'll show you how to input your own information and import custom drawings from DXF files. We'll check compliance against OEM limits and regulations and help you to realize your vehicle's payload potential. We'll briefly touch on center of gravity, static rollover angle, and turning radius. I'll show you how to generate a sign-off document for your customers and how to share your designs with other users of the app. I'll show you where to define your preferences, for example, how you measure your dimensions. And lastly, I'll show you where to find help if you get stuck. We use the login button on the TruckScience website to launch the app, and this little button here to go full screen to take full advantage of the screen space available. To start a new calculation, we must first always choose a vehicle. The TruckScience library includes standards OEM specs as well as generic TruckScience templates. We'll find the Ford that we're looking for in the manufacturer specs. We can browse vehicles by brand and range, such as Ford, Super Duty, 4x4, and we can also filter and search the library up here. We can sort the list by CA and choose this diesel 84-inch CA Ford F550 to accommodate an 11-foot service body. Your calculations may all be different, but you'll go through the same process every time to input information and generate results. We're going to use the left-hand side of the screen to input your vehicle, body, equipment, and payload information. The bottom part we'll use to verify compliance with manufacturer and regulation limits and to determine maximum achievable payload. In the right-hand side, we switch views and examine outputs. And at the top, we can print, save, and share our calculation, as well as define our preferences. You'll note as we go along that as we make changes, the drawing, compliance scorecard, and weights table are all updated in real time. Let's start adding some components now. When deciding whether to add an item as a body, equipment, or payload, we consider the following guidelines. A body has payload capacity, whereas equipment does not. Equipment is permanently attached to the vehicle, whereas payload is loaded on and off. Let's add a body using the second icon here on the left. You can choose from these predefined categories or other if your body category is not shown. Let's add a service body. The library areas at the top: template, personal, team, and public. You can search the public library for preloaded bodies from well-known brands such as Reading. Since this is a standard spec from the Reading website, a regular user does not have permission to edit its dimensions. So we'll use the scissors to remove this body. We found the Reading body in the public library, but now we're going to use a TruckScience template to design our own. Templates have more generic drawings, but offer greater flexibility in terms of what you can edit. Now is a good time to point out the color-coded indicators beneath the drawing. The compliance scorecard on the bottom left indicates if manufacturer ratings or bridge weights have been exceeded. Green indicates that everything is good so far. You can click on the title of the scorecard to switch to regulations for your state. We've recently added regulations for California, Illinois, and New York. A further 19 states will be added next month, including Colorado, Georgia, Idaho, Iowa, Maryland, Michigan, Ohio, Texas, Virginia, and Wisconsin. The weights table shows a breakdown of weights per component and across the axles. It also shows the maximum achievable payload for the current setup. This figure is highlighted here in blue. Blue text on the drawing or in the weights table indicates a shortcut. Shortcuts open the menu on the left at the relevant attribute. For example, front axle weight or body length. You can pop this dialog in to return to the menu on the left-hand side. Defaults are provided but should be overridden where you have more accurate values. Note that the graphic and weights table update on the fly. If I set the body length to 133 and the height to 38, you'll see the drawing updated. You can also update the material weight from, say, 120 pounds per foot to 91 pounds per foot. You can toggle between weights in pounds per foot and absolute weight. Reducing the weight of the body increases the maximum achievable payload. You keep an eye on this blue figure here in the weights table. You can use these undo and redo buttons at the top to reverse most recent changes. Let's add some equipment now using the third icon on the left-hand side. We're going to select a crane to add a crane first. We can again search the public library by brand. I'm going to search for a Liftmore crane. You'll note that our payload figure has decreased with the addition of this crane. Watch how the weights change as I drag the crane towards the rear. You'll also see that the crane weight has been included in the unladen total here in the weights table. Next, we'll add a generator. Since we don't find a generator category here, we can search for it in the other category. You can position the generator as we did with dragging of the crane, or you can open the menu again to specify its position. We'll move it to 4 inches from the back of cab, 26 inches above the chassis. We're going to add a step as well. Again, we'll add this in the same way in the other category. Search for step. We hover until it goes blue. And drag it into position. You can click on it to refine this position in its position tab here. Let's override its weight in the specification tab. And specify its center of gravity. If you're unsure where the center of gravity is measured from, just click on the information icon. You will see that it is measured from the front of the item itself. We specify the center of gravity as being at 45%. Again, this can be specified as in absolute terms in inches. We should probably add some outriggers, but I'm going to skip that step to save some time here. So as you've seen, you use the icons on the left-hand side to input your information. You'll find output views here on the right. We can see that we're in the side view. We can switch to top view using this button. We can click on the body to edit compartment depth. And then we want to position the equipment laterally. So I'm going to move the crane to curbside and the generator to roadside. This will affect lateral center of gravity and the rollover stability. Let's go back to the side view to examine our payload now. To do this, we need to understand the difference between the vehicle's payload potential, the maximum payload of the current configuration, and user-defined payload. We'll start with payload potential, or potential payload. The total weight of the vehicle is constrained by the total permissible or the sum of the axle permissibles, whichever is less. The permissibles themselves are derived from the gross axle weight ratings or the gross vehicle weight rating, and the limits defined by your chosen regulations, whichever of those is less. In this case, the maximum weight permitted on the front axle is 6,500 pounds. On the rear axle is 13,660 pounds, and on the total, 18,000 pounds. These are all limited by the OEM rather than the bridge limits, which, as you can see, are much higher. Therefore, the total permitted weight of this vehicle, including payload, is 18,000 pounds. This is reflected here in this permissible figure. Potential payload is what is left when you take the weight of the complete vehicle, or total unladen, specified here as 10,265, from the total permissible weight of the vehicle, which, as I said, is 18,000 pounds. In this case, that figure is 7,735, which happens to match this auto-calculated payload figure in blue of 7,735 pounds. Therefore, we are realizing the vehicle's maximum payload potential of 7,735. We'll get to user-defined payload later, but for now, we have a proposal to agree with the customer. The vehicle's GVWR is 18,000 pounds, and the payload capacity with our current configuration is 7,735 pounds. We're going to send this design to our draftsman now to get a more realistic body drawing to replace this template for our customer sign-off document. So I'd first save the calculation. And then we'll use this icon to share it with somebody else who has a license for TruckScience. We'll send it to this draftsman email address. We can include some comments about our design and invite them to view it. After some time has elapsed, then, we can replace the template body drawing with the drawing we received back from our draftsman. So we're first going to take off this template body using the scissors. Sorry, I'm in equipment. I need to go to body. And this time, we're going to use the Import DXF feature. If you go to the end of this list, you'll find this Import a DXF file link. And we're going to choose a file from my own desktop. This is the drawing that I've received back from my draftsman. We line it up if necessary, specify its length. Indeed, if your draftsman has a license for TruckScience, they could do this step for you, or your engineering team. It's going to give it some dimensions here. Remember that the compartment depth was 25 earlier. Specify a weight for this body, 997. Give it a description. So my service body, whatever your own naming convention is. and add it to the drawing. I'm just going to drag it down. I forgot to specify this dimension when I was importing my DXF. If I go back into the body, I can save it here to my team library so that others can use it in future, others on my team. I can also choose to share it to the public library so that all users of TruckScience can use it and in that way promote it to the wider community. If I do that, I can specify read-only permissions or editable permissions for those users. The default is read-only. Up to now, we've been using the default or simple payload. This is an evenly distributed load, such as sand or water. We're going to add some user-defined point loads now by switching to detailed payload. You've got these by now familiar library areas of template, personal, team, and public. We'll add a generic payload template. I can hover and click on it to open the menu, or again, I can open it from the left-hand side here. But let's give it a recognizable description, such as tools. Specify its position. We'll bring it in a little bit from the edges, 2 inches. Specify a length, 32, 32, and a width of 23. Now I'm going to give it a weight of 750 pounds. But first, I'm just going to try a typo, 7,500, to show you what happens when an axle becomes overloaded. We've run into compliance issues, as you can see by the red color coding. The scorecard flags issues with the manufacturer ratings, and the weights table shows that the front axle is overloaded. Let's review again where this front axle limit comes from. We click on this permissible value for the overloaded axle. We see that the permissible or maximum permitted weight for this axle is 6,500 pounds, which is derived as the lesser of the gross axle weight rating of 6,500 and the bridge limit of 20,000. In this case, the GAWR is lesser. Upgrading an axle can sometimes make this problem go away. So let's try upgrading the axle to 8,000 pounds. Because we already saw that we had a maximum payload of over 7,500, we can undo that change. And we can address the compliance issues by dragging these tools towards the rear axle. As the front axle weight decreases and the rear axle weight increases, we reach a sweet spot at which no axles are overloaded. If we go too far back, the rear axle becomes overloaded. Remember that blue values are shortcuts, so we can use the payload link on the drawing to update the weight of this payload item. Back to what we had originally intended, which was 750 pounds. I'm going to add a trailer now. So first we'll need to add a hitch. I can click on the hitch to reposition it. Or drag it. And then we go to this trailer one icon to add a trailer. Once I've added a trailer, I get these new body, equipment and payload icons, just like we had for vehicle above. If I click on the trailer payload, again, I can switch to detailed payload. and add a sample bobcat. You can note that the tongue weight is expressed as a percentage of the total trailer weight, that is the trailer and its payload. You can drag the bobcat to increase or decrease this tongue weight. So to center the bobcat vertically, we switch to top view. And back again to side view. You can explore these views in detail in your own time, but let's have a quick look at a few of them now. Go to this overview to see a detailed breakdown of vehicle and trailer unladen weights. You see them here in the table below. We switch to the bridge view to compare actual weight on each axle group with the permissible weights on those groups. You can switch to center of gravity view in the summary to review center of gravity points, including the overall vehicle center of gravity. You can pin any that are of interest to the drawing, for example, the crane center of gravity, simply by clicking on the point. We're going to switch to the turning radius view now to see the smallest circle in which the truck can turn. We can review these notes and warnings to see the static rollover angle of both the vehicle and the trailer. You can go back to side view. To export the current view to a PDF document customized with your logo, you click this PDF icon. The PDF includes a sign-off area, and you can print, download, or email it to your customer. Here's the sign-off area here. At any time while using the app, you can reach out for help by opening this chat feature here. When you're finished with the calculation, you simply save it and head back out to the home screen. I actually will save it in case there are any questions about it later. I just want to point out a couple of things on the home screen before we wrap up here. You can reset the filters by just using this reset button, because we had filtered this list by Ford 550, etc. In settings, you can specify whether you prefer to measure from bumper to back of cab or from front axle to back of cab, and whether you prefer to use the cab to axle dimension or the wheelbase dimension. You can define your preferred measurement system, metric or imperial in here, and how much you'd like your dimensions and weights to be incremented by when you use the up and down tickers from within the app. You can switch between US federal, Canadian, and state regulations in here. You can customize your reports with your own logo here. This is where you add your logo. And you can add your NTA username and password here to qualify for a discount on your subscription, or indeed an extended trial of 30 days. In this resources section at the bottom left, you'll find webinar recordings, explainer videos, and useful documents such as OEM bodybuilder manuals. The calculations shared with me are calculations belonging to other users which they've chosen to share with me, in the same way that the calculation was shared with the draftsman earlier. My saved calculations are pretty self-explanatory. You can perform the usual file management tasks here, like renaming, organizing them in nested folders, etc. Lastly, when choosing to open a new calculation, I showed you how to reset the filters. If you don't find the vehicle that you need, you can request it here. We could have requested a vehicle to be added to the library, or, of course, we can start with a generic TruckScience template. The template graphics are not as pretty as those of the standard OEM specs, of course, but there is much greater flexibility in terms of what you can edit. So it may be the best option, especially if you're in a hurry for a vehicle and it's not yet in the library. We're going to wrap up the demo there, but before I do that, I'll just quickly ask Jens if anyone would like to come in with some questions while I still have the screen open.
Hi, there have been a couple of questions, but the latest one I was about to answer here on the chat is from about whether one can print the side and top view at the same time, or does one need to do them separately? And the answer to that is one needs to do them separately, but I'll add that to our to-do list, that one can print them at the same time or select a number of views to print in the same PDF. We release new builds of the app every 8 to 12 weeks, and we prioritize features based on customer feedback. And I see now there's a new question from around are the bodies classified by year? And the answer to that is no. The vehicles are classified by year, but the bodies are not. And here's another one. Is there a lowboy trailer template that you can change the axle spread? There isn't at this stage. There is a lowboy standard trailer, but if you have different options of lowboys, you can send those through to our support team to have them added to your personal library. So you can add different options of axle spreads, and they'll get that uploaded for you. There's a question on what are the steps for creating and importing a DXF? Is it possible to create our own templates? Sergey, I wonder, do you want to just go over the DXF import again? Is there time for that?
Yeah. Okay, so I'll just click on this body to remove it. And you'll find the imported DXF file link at the bottom here. Choose a file from your own desktop. And I should just point out that when you are choosing a DXF drawing, the less lines that are in it, the better. So you don't want a very, very detailed drawing that will slow down the app as you're dragging and moving this body around. So if the file is too detailed, it's worth maybe reducing some of the detail in it. In fact, there is a limit to the size of the DXF you can import. So the first step is to position it at the required XY. I didn't have to do that with this one because there are no protruding pieces. But in a case where there's something maybe in the drawing that protrudes past the cab gap or the chassis, you might have to move it. Then we just go next here. I specified the body length of 133. Cross member height of 5. The height of the body is automatically scaled from the drawing. So once you've specified the length, the height is automatically calculated. And the chassis top to body bottom. So this is what I forgot to do when I showed you earlier, which would have positioned the body correctly on my drawing. And then if we just go to width, I think it was 94. Specify the width of the compartments. Again, this is just for the top view. And we have the body weight. You can also specify that the center of gravity is possibly a little bit closer to the front, maybe. Sorry, just show you the rest of those fields. You have the similar fields for payload center of gravity if those are relevant. And then you simply give it a name. It's automatically added onto my drawing, but if I click on it once more, I can save it. If I save it to my personal library, it will only be usable by me in future or visible by myself. If I save it to my team library, it will, as the name suggests, be accessible by anybody else on my team. So I mentioned that maybe the draftsman or one of the engineers on the team might perform this step for the salespeople. And then if you want to promote it to the TruckScience library, you can optionally do that and specify the level of permissions you want to give anybody else who's going to add this to their drawings. Yeah, Richard wondered if you could create your own templates, and of course you can. Not your own templates, sorry, but your own. You can import your own standard items. So I know that we've covered a lot in a very short time. So if you feel that you still need a personalized demo, either as an existing user of the app or somebody who's interested in using it, we'd gladly set that up for you. The subscription includes free support, so at any time that you need help with anything, you're welcome to reach out by phone, email, chat, or in any other way you can think of. If you do have any questions that come to you after the session, you're welcome to leave them, to email them to us or leave them in a comment in the chat at the end. So if you're not already using TruckScience, we'd invite you to take a free trial from our homepage, truckscience.com. If you add your NTA membership detail in the settings area, your trial will automatically be upgraded from 7 to 30 days. And NTA members also qualify for a discount. That's pretty much all for today, folks. I think we've come in under time. We might still have some questions. If there are any, please feel free to raise your hand or type in the chat. I am going to end the webinar in just a moment if there are no questions. But before you go, I'd just like to ask you to rate the webinar, and you will be prompted automatically to do that, and leave any comments or questions.
So guys, see there's a question here. Are there plans to add regulations for Canadian provinces? It looks like just a national standard at the moment. Yes, there are plans. We add regulations just like features based on customer requests. So the more people that request the regulations, the higher they get put up the priority list.
I'll leave it at that then. Thanks very much for joining us. Bye-bye.